All right, so today we're going to really get into this whole chemoinformatics thing.
Yeah.
It's a it's a pretty fascinating topic, right?
Yeah.
Using computers and stuff to like figure out chemistry.
Yeah, definitely. So, like, think of it this way, right? Like, instead of mixing stuff in a lab all day long,
Mm-hmm.
chemoinformatics uses computers
Yeah.
to work with chemical information.
So it's really like a different way of doing chemistry.
Exactly. Yeah, like super smart computers to solve these, like, really tricky chemistry puzzles,
Right.
you know?
Yeah. And so we've got a whole bunch of sources here, articles, research papers, all sorts of things about this. What we're really trying to do today is figure out, what this chemoinformatics thing is all about, where it's going, and why it even matters to folks like you listening in.
Yeah, I think one of the coolest things about it is that it really helps speed up research, right?
Okay.
So instead of like spending years and years in a lab just trying different things out,
Right.
we can use these computational models to like basically simulate those experiments.
Oh, wow. So you can use really kind of
Yeah,
test things out in the computer,
exactly. Yeah. And see what's likely to work and what's not.
like way faster.
Way faster.
Yeah.
And then you can focus your efforts in the lab on the things that are actually promising.
That's pretty wild.
Yeah.
So how does it actually work? Like, what are we talking about here?
So basically, chemoinformatics is all about data,
Okay.
like tons and tons of data on molecules, right? Like how they're structured, what their properties are, how they interact with each other.
So this is beyond just like, having a list of chemicals and their names or something.
Oh, yeah, way beyond that.
Okay.
We're talking about like, imagine having a blueprint for every single molecule out there,
Wow.
and then being able to like analyze that data, find patterns, and even visualize it in different ways.
Okay.
So you can actually see.
Like, it's almost like having
Yeah.
some sort of like supervision
Yeah,
where you can look at a molecule and see how it works.
exactly. And you can see how it interacts with other molecules,
Yes.
like how it would behave in different situations. It's really powerful stuff.
So this is like way beyond what like, a chemist could do just sitting there with their, beakers and test tubes and stuff.
Exactly.
Yeah.
Yeah, it's like taking all of that knowledge
Mhm.
and then amplifying it
Yeah.
with the power of computers,
Right.
you know?
That's pretty amazing.
Yeah.
And so what are like the big areas where this is really making a difference? Because I know our sources mentioned a few key things.
Absolutely. So one of the biggest ones is drug discovery.
Oh,
Right. Like think about trying to find a new drug to treat a disease.
right.
Traditionally, that's been a really long and expensive process.
Yeah.
But with chemoinformatics, we can actually screen millions of molecules virtually
Oh, wow.
to find the ones that are most likely to be effective against that specific disease.
So you're basically doing like a virtual experiment
No, it's like a virtual lab.
in the computer
Exactly.
before you even
Before you even step foot in the real lab.
start messing around with the chemicals.
Yeah, and that saves so much time and money. It's incredible.
So it's like being able to test out a million different Lego combinations without actually having to like build them all.
Exactly. It's like a super advanced virtual Lego set
Right.
for molecules.
Right.
And then another big area is material science.
Okay.
Like trying to design new materials with specific properties.
Right.
So, for example, if you want to make a new plastic that's stronger and lighter,
Okay.
you can use chemoinformatics to simulate different molecular structures
Wow.
and see which ones are most likely to give you the properties that you're looking for.
And then you can actually go and try and synthesize those, right?
Exactly, yeah.
That's incredible.
So it's like custom designing materials at the molecular level.
And this is happening like right now. This isn't like some sort of sci-fi future
It
stuff.
is happening right now.
Wow.
Yeah, it's pretty amazing.
That's really cool.
And then another area where it's making a big impact is in chemical synthesis,
Okay.
like figuring out the best way to actually make those molecules.
Mm-hmm.
Right. Because sometimes those molecules can be really complex.
Sure.
There might be like a million different ways to try and make them.
Right.
But with chemoinformatics, we can use algorithms to find the most efficient synthetic routes.
Okay.
The ones that are going to use the least amount of starting materials,
Right.
the least amount of steps, and generate the least amount of waste.
So it's like optimizing the whole process.
Yeah, exactly. It's like
Yeah.
having a GPS for chemistry.
Yeah.
It tells you the best way to get from point A to point B,
That's a great analogy.
you know?
I like that.
So yeah, it's a really powerful tool for like making chemistry more sustainable
Right.
and more efficient.
I mean, it sounds like this is really revolutionizing like all sorts of different areas of chemistry.
Yeah, it's definitely a game changer.
Yeah.
It's really changing the way we do chemistry.
And so for you listening out there, what's really cool about this is that it shows how computation isn't just about like spreadsheets and numbers.
Yeah.
It's really a fundamental tool for like reshaping how we do science.
Mhm.
Excellent. And it's not just chemistry, right? This is happening in all sorts of different fields.
Exactly. Yeah, we're seeing this kind of data-driven approach being applied in biology, in physics, even in the social sciences.
Right.
It's really becoming a universal tool for like uncovering new knowledge.
Yeah, it's like we're learning how to extract really useful information from all this complex data that we're generating.
Yeah, and the more data we generate, the more powerful these tools become.
Right.
It's like a positive feedback loop.
Yeah.
It's really exciting.
So to sum all this up, chemoinformatics is basically using the power of computers to speed up research in all sorts of areas.
Exactly. Yeah, new medicines, new materials, you name it.
It's really changing the world around us.
And for you listening out there, the big question is, how are these kinds of computational approaches changing other fields?
Right.
Like, think about the areas that you're interested in.
Right.
How is data analysis and computation impacting those fields?
How is it changing the way we understand the world?
Yeah, that's something to really think about.
All right, well, that's our deep dive into chemoinformatics.
Yeah.
Really fascinating stuff.
Yeah, it is.
Thanks for joining us.
Thanks for having me.
We'll see you next time.
See you later.